Another application of exponential equations is that of radio decay. In particular, in this video, we will be dealing with half-life. And half-life is simply the amount of time it takes for half of a substance to disappear. So for example, if I have 10 M&Ms and the half-life is 1 hour, then after 1 hour, only 5 M&Ms will be left. And then after another hour or 2 hours total, there will only be 2.5 M&Ms left. And then after 3 hours total, there will only be 1.25 left. This comes into play in particular with something called carbon dating. In our generalized equation, notice it's still of the same form, f of x equals a to the x power. Again, we're using t because we're dealing with time. But one place we see this a lot is in dealing with something called carbon-14 dating. Again, this stands for the amount of the substance after time t. Just like with our population models, this is the original amount. This is our decay factor in this case, and then our t is the time passed. In this question, we're being asked to determine A so that the function accurately describes the decay of carbon-14. To solve this, you have to know the half-life of carbon-14. I'm going to tell you that the half-life is 5,728 years. And what that means is if you had 100 grams of carbon-14 in 5,728 years, you would only have 50 grams. We want to solve for the A value. So we're going to take this A of t is equal to A naught equals A times a to the t power. We're trying to solve for a. Well, we know the half-life, so we can make up a number. For example, let's do the problem I just said. Let's consider that we start with 100 grams, and in one half-life, which is 5,728 years, there will only be 50 left. Dividing both sides by 100, we get that 1/2 is equal to a to the 5,728th year. Now here's the part where it gets a little bit tricky. We have to get rid of that exponent of 5,728. So to do that, we're going to raise this to the 1 over 5,728th power. But what we do to one side, we must also do to the other. And this should be a 28 here. So what you can do is you can plug into your calculator in parentheses 1/2 raised to the 1 over 5,728th power. And what you will find is that A is equal to 0.9999 if you round off. That is our A value. We can then plug that back into our equation to determine the amount of substance that would be left after a given time.